Hello everyone. We're in the last topic of Spiral 1. It's all about graphs and relations. So we're going to look at what those are and how we work with them over the next series of lessons. Our first lesson is on scatter plots and lines of best fit. We're going to look at what those are and how do you make them and how do you work with them and what do they mean. You can pause the video whenever you need to, and you can update your notes as we follow along. The first thing you need to be reminded of is what a Cartesian plane is. So this is the name of a coordinate grid. So you may remember you've got an x-axis, a y-axis, and you plot points on the grid. So these variables, x and y, they often represent things that you can measure or count in the real world. So, for example, our variables x along this axis and y along this axis, they could represent time and distance, or as we'll do later, it could be your height and your arm span. You could make a graph of the relationship between these two things. And those two things that you're finding the relationship of, those are called variables. And when we graph those points showing the relationship between our variables, this is called a scatter plot. And you can see some examples of a scatter plot down below. So here we have our x-axis, our y-axis, whatever they're measuring. So it could be time and distance in seconds and meters. And we could have different points showing the relationship between those variables. So that's what a scatter plot is. Now, when you look at each of these scatter plots, so I've got 5 of them down here, you can see some of them, there's a clear relationship. Some of them, the relationship is a little less clear because the points are not all in line. But that's where the idea of a line of best fit comes in. This line follows the trend of the data. So if I look at this first scatter plot, it looks like the trend of the data is an upward line. So I could draw this line to follow the trend, and that would be my line of best fit. It's the line that best fits all the points. If I look at my second example of a scatter plot, I can also see the trend in the data clearly decreases from left to right. So my line of best fit would follow that trend. So for the first 2 examples, it's really clear where to draw the line. It's the line that goes through all the points. But what if your points don't follow a clear line? Well, that's where the best part comes in. It's the best fit. So if I look at this scatter plot here, we have to think, what is the trend? Well, if I read the graph from left to right, it looks like the dots are going upward. So that's the direction my line is going to go. So I have a line following the trend of the data, and I wrote this, it is not a dot to dot. So don't feel like you have to make your line somehow touch every single dot. No, you're following the trend. In general, these dots are going upward. So that's the direction my line goes. Some tips, you want to go through as many dots as you can, but also follow the trend and have the same number of dots on either side of the line, roughly. You kind of just have to eyeball it. If you want a really precise line of best fit, you would use graphing software on a computer to do that. For this scatter plot, what's the trend? Well, if I look at the graph reading from left to right, it looks like the dots are decreasing. They're going downward. So my line of best fit would follow that trend, and it would fit the dots as best as I can get it. So I want to have the same number of dots roughly on either side of that line. What about this scatter plot? where would the line of best fit go? There's no clear trend here. Because the dots, they might be increasing, they might be decreasing, they might be going level, or I don't know. You can't tell just by looking at the graph what the trend is. So we would just say there's no trend. We can't draw a line of best fit. If there's no trend, you can't have a line to describe a trend. Also, sometimes you get a scatter plot where it looks like there's a trend, but it might not be a linear trend. So you would not draw a line of best fit for this one as an example. You would not draw a line of best fit for this one as an example. We would say these are non-linear. And when we have a non-linear relationship, you might have a curve of best fit. And you could extend those lines if you zoomed out on the graph, and you could follow the trend, follow the curve in either direction, and you could have a curve of best fit instead of a line of best fit. This one in the middle, it looks linear, so we would have a line of best fit. Now, this is something I was going to have you do in class, but obviously we're not going to do that part, so I'll just provide some information for you. We're going to complete a table of values. So you've probably made a table of values before. So this would be review if that's the case. So table of values, you have your variables, and you're going to collect different pieces of information for each variable. So what I was going to do in class was have each of you measure your height and your arm span. So arm span would be if you stick your arms out to the side, it would be the distance from the tip of your finger over here to the tip of your fingers over here. So each person has a height and an arm span. When we fill in our table of values, you would have the information for each person. For example, my height is 178 centimeters and my arm span is 180 centimeters. So that would be one entry in my table of values. Last semester, I had someone in my class who was 155 centimeters tall, and they had an arm span of 151 centimeters. So that would be another entry in my table of values. So I could measure a bunch of people's heights and arm spans, and I could get an entry for each of them. So for each person, I'm measuring 2 variables. Now over here I have a question. Which variable is independent and which variable is dependent? So those are some words that we're going to be using to describe the relationship between our variables that we're measuring. And sometimes it's hard to determine which is which. So you have to think about, what does it mean? Independent means it's not dependent on something. Dependent means it does depend on something. So for our purposes, we have to think, does your height depend on how long your arms are? Or does how long your arms are depend on how tall you are? So sometimes the relationship might be a little unclear which is dependent on the other. For this one right here, our height is independent of our arm span. Our arm span is dependent on our height. Another way you can think of it is your height determines your arm span and not the other way around. So the taller I am, of course, the longer my arms are going to be. However, just because my arms are long does not necessarily mean that I'm going to be tall. So again, a lot of people find this confusing. It really just takes practice to determine which is dependent and which is independent. Now, the reason we need to know this is just for communication purposes, really, in math, when we draw a graph, our independent variable goes on the x-axis and our dependent variable goes on the y-axis. So when we make a scatter plot, whatever our independent variable is, that's the one we put along the horizontal axis, and whatever our dependent variable is, that's the one we put along the vertical axis. And that's just standard form. That's the reason we need to know which variable is independent and which one is dependent. So now I would actually like you to practice making a scatter plot and drawing a line of best fit. So you can go back in the video to where I showed you the table of values, and you can try to create a scatter plot. So I've got a basic template here. You might need some graph paper. If you don't have graph paper, you could buy some, or you can easily just go into Google, type graph paper, and you can just print some off. That's probably the easiest thing to do. So when you're making a scatter plot, remember our independent variable goes along the x-axis. So in this case, that was height. So when I put my titles on my graph, I say what the variable is that I'm measuring, and then in brackets I indicate what units I'm using to measure that variable. So in the table of values I showed you, I was measuring height in centimeters, so I would indicate that on my scatter plot. My dependent variable was arm span, so that will go on the y-axis. Now the next part is where a lot of people have trouble, it's in making the scale on your grid. A lot of people run into the issue of they just write the numbers that they see on the table of values and they just plug them in one after the other on here. That's not what you want to do. You want to have a consistent scale. So we're going to start at 0 and we're going to go up by 5s or 10s or whatever, as long as each square on the grid is the same consistent value that you're increasing every time. So if between the first and the second line you're going up by 2, you should still go up by 2 going to the next square, and up by 2 again, up by 2 again, up by 2 again. Or if you're going up from here to here, you're going up 5, then you should go up 5 every single time. Another thing that people run into problems with is knowing what to go up by. So what is the scale that you use? For that, you want to look at what is your lowest value in your table of values and what is your highest one. And once you know that, then you just think, okay, how many squares do I have? What would be a nice number to go up by so that I can include all my points? So as a reminder, I've just put the table of values off to the side so we can see it. If we look at my table of values here, for height, my lowest value is 151. My highest value looks like 185. So I would want to make sure that I have enough space on my x-axis to fit all of those values. Another thing you can do is you can skip some values. If you don't want to start at 0, you can use this little symbol on the axis to indicate that you're skipping numbers. So if I have this, I'm saying I'm not starting at 0. I'm going to skip ahead to 110 centimeters. The reason I can do this is because if I look at all of my values that I've recorded, they're all in the hundreds. They're all above 150 actually. So you probably could skip ahead even more. I just chose to start at 110. And we can do the same thing with the arm span. So just remember, when you're setting up your X and Y axes, you want to make sure you have a consistent scale. So you'll notice every 2 squares on the grid, I'm going up by 10. Every 2 squares, I'm going up by 10. And it's consistent every single time. What you don't want to do is just write these numbers on your scale. Now to make my scatter plot, I'm going to take each individual person and plot their point. So my point would be the point corresponding to this here. I have a height of 178 centimeters and an arm span of 180 centimeters. So in my mind's eye, I would find a height of 178 centimeters and an arm span of 180 centimeters, and I would find the point where those two values meet. And now I would go to the next entry on my table of values, a height of 155 centimeters, an arm span of 151. And I would plot that on my grid as well. So I would do the same for all of my entries. And if I had more people, I would have more entries on my table of values, which would mean I would have more points on my scatter plot. As you can see, for the points that I do have, it looks like there's a trend, an increasing trend from left to right. So when I make my line of best fit, it would look something like this. So I've just kind of eyeballed it. It looks like it's going through the points evenly, so it's evenly distributed on either side of the line, and it's following the upward trend of the data. And now, once I have this, I can start asking questions. So for example, my wife is 163 centimeters tall. We're going to use the line of best fit to predict her arm span. So when you make a scatter plot, you can start to use your line of best fit to make predictions. Okay, so if I look at my line of best fit, my wife is 163 centimeters tall. Well, that'd be about here. And I want to predict her arm span. So I'm going to use my mind's eye, draw a line up from 163 centimeters of height, go to my line of best fit, and then look over. What arm span is that? Well, looks like it might be about 163. So if I follow the line of best fit that I drew, it looks like for a height of 163 centimeters, you're going to have an arm span of 163 centimeters. So that's how I would make my prediction for her arm span. Now, I have this word off to the side, interpolation. So interpolation is when you are making a prediction for values that are within the points that you have recorded. So that 163 centimeters, that's within these points that I already have on the graph. My next question is an example of extrapolation. Pascal Siakam is a player on the Toronto Raptors, basketball player. He's 206 centimeters tall, and we want to predict his arm span. So I'm going to go back up to my graph and find a height of 206 centimeters. Well, that's a little bit off my scale here. So if I look at this, each square would represent 5 more centimeters. So there's 205. 206 would be a little bit over here. Go up to my line. Well, it's up here. So if I'm estimating what his arm span would be, well, that's going to be, 207 centimeters. This is called extrapolation because we're predicting a value that's outside of the points that we already have. So that's extrapolation. We're extrapolating the data to find Pascal Siakam's arm span of 207 centimeters. So again, interpolation, we are looking at making predictions within the data we have. Extrapolation is when we're making predictions outside of the data that we already have. That's it for this lesson. You need to be able to know how to make a table of values, how to take the table of values to make a scatter plot, and how to use your scatter plot to find a line of best fit so that you can make interpolations or extrapolations. So if you can do all those things, you're good to go. To test yourself, try these practice questions in your textbook. You can send me any questions that you have, and I will do my best to help.